Good morning, everyone. My name is C.H. Srinath. I am from CSC department. My subject is Design and Analysis of Algorithms. Today's topic about technical perspective building a better hash function. Introduction to hash functions. Hash functions are algorithms that convert data into fixed size hash values or digits. They are fundamental in cryptography, that data integrity, and digital signatures. Building a better hash functions involves improving security, efficiency, and resistance to attacks. These hash functions are algorithms and convert data into fixed size. These hash values are digits, and they are fundamental in cryptography, data integrity, and digital signatures also. This building a better hash function involves improving security, efficiency, and resistance to attacks. This is the introduction about hash functions. This is a figure of the hash function. And next one is key properties of a good hash function. A good hash function should be deterministic and producing the same output for the same input every time. It must exhibit pre-image resistance, making it computationally infeasible to reverse engineer the original input. An avalanche effect is essential, where a small change in input significantly alters the output. And this hash function is good hash function and should be deterministic and producing the same output for the same input every time. And it must exhibit pre-image resistance, making it computationally infeasible. And to serve engineering and reserve engineer the original input. And this essential where a small change in input significantly alter the output. This is cryptographic hash function is used to connect the blocks in a chain in a tamper-proof way, and it take any arbitrary size string has input, uh, a fixed size output, and output h of m is equals to message digest and efficiently computable. And cryptographic hash function properties are deterministic, collision free, hiding, and puzzle friendly. Deterministic always yearly in the identical hash value for identical input data. Collision free is nothing but the if two messages are different, then uh, their digits are also different. And hiding is nothing but the hiding the original message. And puzzle friendly is given x and y, find out k such that y equals to h of k, h of x and k. This is the key properties of good hash functions. And next one is common hash function algorithms. Popular algorithms include MD5, SHA1, SHA2, and SHA3, each with different security levels. Older algorithms like MD5 and SHA1 are now considered insecure due to vulnerabilities. And SHA3 introduced a different construction called Keka and offering improved security features. This is common hash function algorithm, and common hash algorithm explain MD5, SHA1, SHA2, and SHA3 also. These older algorithms like MD5 and SHA1 are now considered insecure due to vulnerabilities, and SHA3 introduces a different construction called Kikak and offering improved security features. This is common hash function algorithms. And next one is challenges in building better hash functions. Increasing computational power makes it easier to perform brute force and collision attacks. Designing functions resistant to quantum computing threats is an emerging challenge. Balancing between computational efficiency and security is critical in hash function development. And increasing computational power makes it easier to perform brute force and collision attacks, and balancing the between computational efficiency and security is critical in hash function development. This is the challenges in building better hash functions. Next one is the improving security against collisions. Implementing complex mixing functions and nonlinear transformations can reduce collision probability. Using larger hash sizes such as 256 or 1512 bits enhances collision resistance. And this continuous cryptanalysis helps identify vulnerabilities and guide improvements in design. This implementing complex mixing functions and nonlinear transformations can reduce collision probability. This a recursive algorithm calls itself with smaller input values, and the results by simply performs the operations on this smaller value or to solve a problem. This is improving security against collision. And next one is enhancing resistance to pre-image and s- second attacks, and incorporating multiple rounds of hashing increases complexity and security. This employing innovative mathematical constructs can make inversion computationally infeasible, and randomized or keyed hash functions can add an extra layer of protection against these attacks. This incorporation multiple rounds of hashing, this increasing complexity and security. This randomized or key hash functions can add an extra layer of protection against these attacks, and this employing innovative mathematical construction can make it inversion computationally infeasible. This is enhancing resistance to pre-image. And next one is optimizing efficiency of hash functions. Parallel processing techniques can accelerate hashing operations without compromising security. Hardware acceleration, such as using GPUs or specialized chips, improves performance and reduces computationally complexity while maintaining security is essential for practical applications. This hash function password encryption, passwords of administrators of in editors, passwords in the database. These are two types of password encryption. This parallel processing techniques can accelerate the hashing operations also. And next one is future directions and quantum resistance. Developing hash functions resistance to quantum algorithms like Grover in active research area. And it post quantum cryptography explores new construction that remains secure in a quantum era. It combining classical and quantum resistance and methods can provide comprehensive security solutions. This is the future direction of quantum resistance. And next one is the uh, conclusion towards a better hash function. Continuous research and cryptanalysis are vital for involving hash function security. This security is a continuous research, and cryptanalysis are vital and for involving hash function. And this balancing security, efficiency, and future proofing remains a core challenge. And this is the balancing security and efficiency also, and future proofing remains of a core challenge. This collaboration between academia and industry accelerates the development of more robust algorithms. This collaboration between the academia and industry accelerates the development of more robust algorithm. This is towards a better hash function. And in this picture we have Um, we have example Sairam Institute of Engineering College, Institute of Technology. This is year fourth and sixth, seventh sem, and cryptography and network security common CSC and IT. This is the example of towards a better hash function. The next one is references. References is National Institutes of Standards and Technology. Next one is thank you.